Some particularly important vectors are unit vectors, which is what we call a vector whose length in our coordinate system is 1. If we place a vector in standard position, this is the same as saying that its tip lies on the unit sphere. There are 3 special unit vectors that play an important role, that is one for each axis of our coordinate system. These are called I, so that's 1 in the x direction, j, which is 1 in the y direction, and k going in the z direction. So we call these the standard unit vectors. And a key property is that every vector in 3D space can be expressed as a linear combination of these vectors. So linear combination means anything you can get starting with just those vectors and adding in scaling. So for instance, if you just took I and j but not k, then the xy plane is everything you could get as a linear combination of those two. So for a general vector, v1, v2, v3, we can break that up into v1, 0, 0 plus 0, v2, 0 plus 0, 0, v3. And then those are v1 times I and v2 times j and v3 times k. So here's what that looks like. So this is like the parallelogram picture, but for adding 3 vectors together. And breaking down vectors this way is extremely useful because oftentimes we can understand a function on vectors just by understanding what it does to I, j, and k. Okay, so that's one way to break a vector into more manageable pieces. Another way is, for any vector, so long as it's not the 0 vector, we can divide it by its length, and then that will be a unit vector. So we call this unit vector the direction of v, and we denote it by v hat. I don't think the textbook uses this v hat notation, but it's pretty common, so you might see it elsewhere. And then we can express v as its length times its direction. And often these 2 pieces of information are more relevant or easier to deal with than the x, y, and z components. Just like in the plane, you can use polar coordinates to describe a point using a radius and an angle. So this is like the 3D version of that. So let me do some examples. So let's say we are given the problem, a force of 8 newtons is applied in the direction of the vector v equals negative I plus 2j minus 3k. So in component notation, that's v is negative 1 to negative 3. And we're asked to find or express the force F as a product of magnitude times direction. So we're given that the magnitude of F is 8, and now we need to find the direction. So v is not a unit vector, so we need to divide by its length in order to find the corresponding direction vector. So v over length of v, this will be negative 1 to negative 3 over square root 1 plus 4 plus 9. So that'll be negative 1 over 14, or root 14, 2 over root 14, and negative 3 over root 14. Or in the ijk notation, negative 1 over root 14, I plus 2 over root 14, j minus 3 over root 14, k. And so now we have the direction. The force is a magnitude of 8 times the direction vector, this unit vector, negative 1 over root 14i plus 2 over root 14j minus 3 over root 14k. And that's our answer.